Hello, everyone. How's everyone doing? Hopefully, everyone's doing great. I'm so excited to be here and so excited to dive into the world of Python or math animations in Python using Manim. It's going to be great. It's going to be really interesting. Just before we get started, let's do a quick activity. I like doing this before all my streams. Just where is everyone tuning in from? I'm streaming from Texas, Austin, Texas specifically. Where are you all based out of right now? Where's everyone watching from? Hello, Oma Ragales. Hello. Oh, from Egypt and Africa. Okay, that's awesome. That is awesome. I don't know if I've ever had anyone actually tune in from Egypt, so that's awesome. You might be the first person on my stream from Egypt. That's great. Uh, Someone else from Texas, Jordan Oss. All right, where in Texas specifically? That's awesome. We got one person here from Texas, so could be neighbors. You never know. Abilene. Okay, I think I've driven through there before. Maybe. I don't recall specifically, you know, how you drive. Just in Texas, you're always driving. So I may have driven through that town. That's really funny. Okay, awesome. So we have people from all over the world. We have two people here from Texas, myself and Jordanos, and then we have some people from Egypt and Africa. That's amazing. So, all right, let's just dive right into this. So before we get started, I just want to give a very quick introduction on Manim. So we're just going to be going through sort of the quick start on Manim community, actually trying to create a new project, seeing how we just do some very simple operations to actually create different Python programs. So it's going to be really interesting. Uh, I will give an example of how some of them might look, and then we're going to move on to sort of more and more complicated animations until by the end we'll have something that looks really cool. All right. Any questions before we get started? Someone said simulated. Yes, so we are going to be going into kind of simulations. There are more animations, and we'll look at how some of those uh, might work shortly. So just to give a quick example of how those look, let me pull it up on this screen. We're going to be doing a very quick, or one of the videos we're going to be working with is a very simple hello world. And an example of how the animation itself is going to look. And again, keep in mind that this entire thing is going to be done purely in Python. So just to confirm, everyone does have a good understanding of Python, correct? It does not have to be expert level. It doesn't even need to be intermediate level. As long as you have a good, solid beginner's understanding of Python, that would go a long way in getting this done. If you do not, Don't worry, I do recommend you install Python really quickly. I do also have a stream from yesterday. It should still be up on YouTube uh, on just getting started with Python. It's Python for beginners. It's a very quick and simple one-on-one course. I do recommend you all check that out as well. And then you can either come back to this or you can follow along right now and then go to that later. All right. Looks like most of us are familiar with Python, so that's great. But let me share my screen and give a quick example of what we're going to be working with today. Yeah, make sure to add my screen. Okay, there it is. So you can see that I have a few things open here. Let's open up like a quick hello world. And this is going to be one of the things that we work on. It is a very quick and simple hello world Python script. And this is essentially what it's going to be saying. So it's just going to be hello Manim. And again, we generate a full video using just Python. There's some other things that we're going to be working on, such as more advanced animations, basic shapes, even a quick graphing example. And we can see one of those here. So you can see there's a whole lot that you can do using Manim. If any of you all have ever watched the videos from this one YouTuber, his name is, I don't remember his actual name, but the YouTube name is 3 Blue, 1 Brown. This is actually the tool that he uses for all of his animations in his videos. And he is actually the one that created Manim and then made it free and open source for anyone else to use. So he has his own version. Then there's a whole community around just supporting the code and making sure everything works with the latest versions of Python. So if any of y'all haven't or have not watched his videos, I highly recommend them. They are also really great. Yes, Grant Sanderson, that's his name. Thank you. Yeah, so again, he's a great person. Uh, puts a lot of his content on YouTube for free, and this is stuff that people pay thousands of dollars for, uh, in you know to learn at like a university level. So definitely check him out as well. And again, there's some other things that we're going to be going over. Also, just creating basic shapes in Manim. So over here, you can see we created a circle and a square and a triangle, and then actually doing transformations on those shapes is something else that we're going to be working on. So you just saw that square morph into a circle and a whole lot more. All right. Now before we dive in, any questions that I can answer? And again, just feel free to put those in the chat. Also, a quick reminder, if you haven't already, do please check into the event. That way we know who is here and you can get credit for coming and maybe get some swag, who knows? Okay, so before we begin, the prerequisites are you do need to have an IDE. I like using Visual Studio Code. You can use PyCharm or any other IDE of your choosing. And then you do need to have Python installed as well. All right, so we can get started then by just creating a new project in a folder. So I just called it Manim Live. I recommend you all can call it anything you want. Again, no recommendations there. You can call it project, you can call it Manim Live, just how I did, anything you would like. So this right here is going to be the root folder of your project, and all the files that Manim is going to need to function are going to be over here, and any output that Manim produces is also going to be here. All right. So what we're going to do is create a new file called scene.py. So it's going to be a Python file called c.py. And then we're basically just going to create a circle. That's going to be the very first thing we do. So from Manim, let's import everything. And then we want to create circle. So we can make a class called create circle and pass in a scene object. And then actually write the function to construct the circle. So construct a circle. So what this does is it just creates a circle And then we actually want to customize our circle a little bit, right? What if we want to color it? So we can actually do circle dot set fill to, what color do we want this? Let's say we want it to be pink. All right. So we can make it pink, and opacity, because we don't want it to be too pink, let's make it 0.5. All right. So over here, we're just setting the color and transparency. Transparency. Okay. And then we want to actually we want to actually animate this, right? So we have the circle, it's all working. We want to actually have this thing play. So self.play. And then we want to actually create the circle. So what this is going to do is actually show the circle on screen. Okay. And now we just want to save this. And then we want to open up our command line. So the way I like to do this is just by dragging up this bottom bar. You can also go up to this top left if you're on a Mac and click New Terminal, or do the Windows equivalent of that, which I'm not 100% sure what it is, but you all are smart. You'll figure it out. If you do have any questions, do let me know in the chat. And then we just want to actually run this. So the command for running Manim files is going to be manim -pql scene.py, or whatever you named your file, and then create circle, which is the class name. Create circle. And then again, on my end, this, okay, unfortunately did work because I do already have Manim downloaded. But if you don't have Manim downloaded, you'll get a little error that says, hey, please install Manim. And that you can just do a pip install and it should all be downloaded. But once we actually run this, we can see that it renders exactly where I want it to be. It creates a media folder, has a bunch of images stored in here if we did have any, and the video now shows up over here as well. So you can see that the video that we just created was the circle, and you can see it's pink and it is half colored, right? It has transparency of 0.5. So congratulations, you all just created your very first math animation. All right, so give yourselves a pat on the back. Now I'm going to go to the chat, make sure no one has any questions. Looks like everyone's good so far or following along. Was everyone able to get this animation to play properly? Hopefully no one encountered any issues with this. So the command to run it is, let me try and increase the size of my terminal. I don't know if I can do that, but it is manim -pql scene.py and create circle. And it basically goes manim, which is the name of the, which is what we're using. pql scene.py is the name of the file, and create circle is the name of the class. So what we did over here was we first imported all the contents of the Manim library, right? And usually the best way to use Manim is actually to do this, unless you're on some really heavy, like lightweight machinery, you need to import everything one at a time. Because we imported scene, circle, pink, and create. All of this was from Manim. So if we didn't just import everything, we would have had to import each one of those one at a time. And you can see that even for a beginner one, that's about 4 imports, right? For a very beginner friendly animation. So imagine if you had a much larger animation, much more complex one. There's a lot more that would go into it. So you want to try and avoid having too many imports. So this is the easiest way to go most of the time. All right. And were you able to get it working? Uh, Chilawa, I think that's your username. Um, Hopefully you were able to get it working. Oh, Adam is here. Hello, Adam. How's it going? Glad you could join us. And okay, yes, I can absolutely paste the command to the chat. Let me copy that over. Okay, there you go. Some package config error. Hmm. If you do run into any major issues, I'd recommend going into the Manim FAQ section. Most of the time, I think a package error might be, let's double check. I'm not seeing anything related to a package error. Here, can you say what the exact error that you're getting is? Okay, got it fixed. Awesome. Glad you get it fixed. Okay, well, this is the, again, very first uh, Manim program, essentially, or animation you all have created. All right, now let's move on to something a little bit more complicated. All right, so you can either, if you if you choose, you can comment this out, or you can erase it entirely. I will comment it out just so that someone else who might join a little bit later also has access to it up here. And actually, while I am here, let me change my screen so that it's a little bit easier for you all to see. So let's go to color theme and make it a lighter. Um, Actually, let me just make it, where's high contrast? There we go. That should be slightly easier to see if you are watching. That way, even if this thing starts fuzzing out a little bit, uh, all the text is at least highlighted and clear. Okay, now let's transform a square into a circle. All right, so for this, again, it's going to follow the same structure as the previous class that we created. So in this case, we'll start with class square to circle to square to circle, pass in a scene, and then actually construct this. Circle equals circle. And then we can honestly just use this same pink circle from earlier. Then we also want to create a square because we're transforming a square into the circle. So let's do square equals square from Manim, so it knows what we have. And then what we want to do is rotate the square. So we're going to be rotating it into this circle. It's not just going to morph in of itself, it's going to rotate. So square dot rotate by pi over 4. Great thing about Manim is it has pi already built in, so you don't need to worry about that. And then, so this is going to be a 1/4 rotation. And then we actually want to play all of the animations. So again, this is going to be using self.play. And then in self.play is where we sort of line by line are going to be creating the animations. So first what we want to do is create the square that's going to be rotated. Square that will be rotated. Then we want to actually play a transformation. So self dot, in this case, play a transform for, and what we're doing is we're transforming a square into a circle. So square into a circle. And again, it is a pretty straightforward language. The majority of it is just syntax. So the majority of how you end up using Manim as a library is just syntactical. So again, self.play, transform a square into a circle. It's not really a difficult concept to grasp. Again, it's just something that you need to know. And that's why we're here. So once we've transformed the square into the circle, let's actually have the animation fade out. So it doesn't just stay on the screen. So we can also do a self.play, again, a fade out of the square. Not square to circle, square. Okay. And this should fade out the square or fade out the animation. And now let's see if we actually run this, what we'll get. So again, we're using this a similar command, only instead of create circle, we are doing a square to circle, square to circle. And this is going to create the animation, and we have our animation here. So let's actually try playing this. You can see we got a square, and that morphed into a circle, and then it faded out exactly as we wanted it to. So see here, it was creating the square at a 90, or yes, it rotated by pi over 4. So it doesn't start off as a flat square, and then it rotates and morphs into a circle, and then the circle itself just fades out. And that is the full animation. So congratulations, that's animation number 2 that you all completed. So let me just clear this out and put the command to run this in the terminal, and then go back to here. Okay, you just had to reinstall it in the terminal. Yeah, that happens sometimes. Again, it's just Python can be finicky with its libraries. So it does make sense that, sometimes you just need to uninstall something, reinstall something, and it works perfectly fine. Other times it's a complete headache to deal with, and it's almost impossible unless you throw away the laptop and get a new one. So I'm glad it worked for you. Um, Hello, Abhinav. How's it going? I'm glad you could join us for this stream. So is everyone else able to get the transformation working on their laptops or computers? Just want to make sure everyone's good before we move on. Oops, there we go. So just put it in the chat once you're done and you got it working. That way we can keep moving. So again, this is a really cool example of one of the great features of Manim, right? Manim can actually implement really complicated animations, because this animation right here is actually really mathematically intensive if you actually try and do it from scratch or from zero, right? Because again, what you're doing here is you're really cleanly morphing one shape into another. So one geometric shape into another geometric shape. And it makes it really easy to do that using just however many lines of code this is, right? So again, that's another reason why Manim is super powerful, and you can make really complicated animations in as few lines as possible. All right. Let's make sure nothing else. Okay, was everyone able to get that working? Yes? Just want to verify before we move on. Still having trouble installing Manim, so it still hasn't been run myself. Okay. Do you know where you're installing it? I would recommend, if you're not able to install it, try a virtual environment and installing it into there. So the command for a virtual environment is, if I go up far enough, is going to be this. So I'm currently using Python 3.11. So if you type in Python, you can just do Python instead of having any numbers after it. I just have multiple versions of Python, so I had to explicitly say 3.11. you can use whatever Python version you have installed, and then -m venv and then .venv. They should open up they should create a venv file for your virtual environment right here. And then what you want to do is actually just activate that virtual environment. So in this case, I would be doing source.venv/bin/activate. And again, this is for Mac. It might be a little bit different for Windows or Linux machines. Now you can see that I have activated the virtual environment and I'm in the virtual environment. So now that I'm in here, if I try running, let's say, square to circle, it is able to run because it uses I think the Manim data from, yeah, it's using the cached data, but I can also just pip install Manim, and it should, again, download everything that I need. And you can see that it downloaded a few more packages that were not in the virtual environment, and then that should take care of it. All right. Hopefully that was all clear. And for the sake of time, let's move forward. And again, if I am going too fast, do let me know. I will slow down. All right, this isn't a race. I want to make sure that everyone understands what's going on, what's happening, and is able to get some, some animations running on their machines as well. So next up, I'm thinking let's just do a quick something with text, right? So text is actually really easy to do in Manim. So let's just do a class hello world, and you'll see that a lot of times, or a lot of the actual syntax or the structure is just repeated. So you can see we have a class repeated. We just need to name the class and then have everything within a constructor that comes after that. So in this case, and you all might even beat me to typing this entire thing, we're just making a hello world. And then again, next up, and you can probably guess it, we have a construct method and pass itself. Then we can just set some text to anything we want. So text equals capital T text in Manim. And let's do hello hackers. Then we just want to actually write that text, but we want to have it actually play, right? So just like we did before, self.play, write text. Write is the command. Text, lowercase t text. Close that out. There we go. And then we just want it to not disappear immediately. So let's have it just stay there for maybe 2 seconds. And we can do that using a wait function. So text is hello hackers. We're playing that, and let's hopefully see if this works. Scene.py for hello world. And when we run this, it renders, and let's see what we end up with. There we go. So you can see that the text over here morphed onto the screen, hello hackers, and then it waited for 2 seconds instead of it just taking 1 second to actually complete, right? And then disappearing, we had a wait timer, so it waited for 2 more seconds, and then the video is over, or the animation is over. Okay. So that is an introduction to, again, how you have really, really simple just text written to the animation. And again, it follows a very similar pattern as the other ones. You can see that when you're actually putting it in self.play, it's usually a verb, right? So self.play, some sort of verb. So self.play, create, that is a verb, transform is a verb, fade out is a verb. So you're telling it some action to do, and then you're saying what object should the action be done on. So in this case, we are writing, which is a verb, the text, which is the object, And then an object, in this case, not being the same as an object in like programming languages, just like the thing in this case. So the thing that we are writing or fading out or transforming is going to be here, or creating in our create circle example. Okay, hopefully that was clear. And it looks like we do not have any more questions right now. So I'll just let everyone catch up, maybe see the Hello Hackers animation. And we'll give it a few more minutes before we move on. Okay. Hmm. All right. Give it maybe another minute before we move on. Were people at least able to get this one running? I can see people having issues or errors in the comments, but I'm not able to see if anyone is able to get it to run successfully. So I do want to make sure that there's at least a few of you all, or the majority of you all, are able to get it running. That way, I know that you're following along and actually coding everything as we do this. Okay, no answer. That is perfectly fine. We can move on. All right, next let's go into just some basic shapes. So we touched on some of the shapes earlier, but let's do, yeah, shapes. We touched on a lot of these shapes earlier, but now we're just going to put them all down or several of them down so that we can see what we can work with. So in this case, again, we want to do a construct method and pass in self. Again, very formulaic. And over here, we're just gonna have circle equals circle, and I'm just gonna be copying a lot of this. And then we have a square equal to square. That did not copy. I can just type it, square, square, and then let's do triangle. Triangle equals triangle. Okay. Now let's we can actually shift these as well. So we can move it around in our animation so not everything is dead center. So let's do that. We can do circle.shift. And let's shift circle to the left. Left. And then we don't want the triangle and the square to be overlaid. So let's do triangle.shift to the right. Shift to the right. Okay. And then we can actually create everything and see it. So again, very straightforward, self.play over here and create do circle. Then another self.play and create a square. And once again, self.play and we create a triangle. Okay. And then we don't want this to disappear immediately, so we can just add a self.wait function for, let's say, 3 seconds. Okay. And then to run this, same exact situation as before, where we do shapes as our class name and run that. It should create, and it says triangle is not defined. I wonder why. Triangle. Oh, yes, missing the letter L would do it. Well, that's embarrassing as well. That's this circle has no attribute. Yes, it shouldn't. Okay. Um, Hopefully I spelled everything correctly this time. Okay, it looks like I did. Great. Okay. So if we see this, we have the circle being created, then the square being created, and the triangle being created. And you can see that they're not being overlaid one on top of the, or they are technically, they're still overlaid a little bit one on top of the other as of right now, but they're not all dead center because we shifted the circle to the left and we shifted the triangle to the right. All right. And you can see that these are by like very specific units. So you can see that these shifted to exactly the halfway point of the circle, right? So the circle shifted left by 1 unit, which is half the, or which is the radius of the circle. And then the triangle also shifted right by half of the length of one of the sides of the triangle. Okay. So let's make sure everyone was able to get that working. Not seeing any comments. No one's having issues. Okay, awesome. IHZZZZ56. It looks like they got it working. That's great. And hopefully the rest of you all were able to get it working as well. We're just gonna give it a couple more minutes maybe so that you all can get that working, fix any spelling mistakes that you might have had, and then we will move on. Okay. So something else you can do is actually use LaTeX in your animations. Now, for me, I actually was debugging this for I think 3 or 4 hours to no avail, but my LaTeX installation does not work, right? But for you all, I will still be walking through this just because I do want to make sure that you all know that this exists because it is something that's really important, especially if you are trying to make math animations. You want to make sure you can actually use LaTeX so uh, you can have more complex, mathematical operations or definitions on your uh, on your animation. So this will probably definitely break on my laptop, but it should work on yours if you have if you have LaTeX installed. And again, LaTeX is a pretty big package. I think it's almost like 5 gigabytes because of how many ways you can define anything mathematical. So it's going to be a big package, so you will have to wait a bit for the installation. But if you are able to get it working, then I promise you the wait is worth it. So let's do a quick text example. So we can do class LaTeX example with a scene. And over here, we want to, again, just construct text equals text for Manim LaTeX example. Or we can do LaTeX equals math text. And this is what's going to be doing sort of the LaTeX. And let's do something simple. E equals MC squared. Then we can text dot shift up because we don't want the text and LaTeX to be on top of one another. And then LaTeX dot shift down because again, this will only move it up by 50%. Caps down. Okay, now we actually want to have all of this show on our screen for the animation. So self.play, do write the text And then we can also do self.play, write the LaTeX, and then self.wait, maybe 2 seconds. Okay. So if I run this, LaTeX example, you'll see that it tries to actually run this, but again, LaTeX itself failed because um, my LaTeX installation is corrupt. Again, I do recommend you all install LaTeX and try to get that working on your end. But for me, I've been trying, I promise. I really wanted to show you all how a LaTeX animation would look, but unfortunately, I'm not able to. Something having to do with just the installation being somewhere it shouldn't, even though I tried to install it properly. So if you are able to get it working, though, do let me know because I want to make sure that at least one of you all was able to get it working. All right. So I'm just going to leave this here for maybe a couple more minutes to make sure that everyone else is able to catch up and write that, as well as maybe install LaTeX if they haven't already. And again, if you don't have it, you can go to their website and then download it from there. That way, you can also run some of these. Let's see. Yeah. I am not gonna try and debug this entire thing right now again, but again, do let me know if you were able to get it working with LaTeX, just because I think that's cool. If you're able to get it working, then I'm happy, right? Even though I was not able to get it working. Okay, that should be enough time. So let's move on to something, again, a little bit more complicated. And this is just going to be sort of more advanced animations. And in this case, we're going to be doing sort of multi animations right now, and it's going to look pretty cool. So we're going to have like multiple um, shapes rotating in different ways. So let's see how that might look. All right. I'll just comment this out. We can move on down here and then class. Let's do different rotations. Different rotations and seed, and then construct. And then we want to actually have the animation itself play. So the way this is going to be is, let's say we have a square on the left, square, square is going to be equal to a square. And we can actually set the color in here itself. So let's say we wanted to set the square to color equals blue, fill opacity, and this is again another way of filling out the transparency level of it. So opacity to So we want this to be darker, so 0.7. 0.7, and then we want to actually shift this. So again, you can chain these commands by, I'm going to shift this left by 2, that way we're not overlapping anything. Okay, so this is going to be the left square. Then we can have another square on the right, so let's call that one, you guessed it, right square. Set to, again, square, and let's change the color for this one. Color equals, let's make this one green. And let's make the fill opacity the same, which is 0.7. And we want to dot shift. Let's shift this one further out too. That way we're not overlapping, or we're not too close. And then we want to actually do the self.play. Okay, and now this is going to be a little bit longer and again, more complex of a command. So let's have it move to the next one, next line, and left square dot animate dot rotate by pi, and then let's rotate the right square as well. By an angle of pi, comma, runtime equal to 2. So we're going to have these both rotating for 2 seconds, and then we'll just have a self.wait for another 2. Okay, let's see if we made any mistakes here. Pi and different rotations. Okay, nice. It did render. So you can see we end up with 2 squares as expected, right? So we didn't actually have it create the circle and square in the animation itself as we did in the previous ones, right? This one, we had these squares actually show up from the beginning. So the create actually creates those, so that actually writes them out. Now you can see over here, we just had the square in the play itself. So it animated all of those. And if we hit play, we can see that one of them is morphing in and out, and one of them is actually being rotated. All right. So the left square animation is a rotation in itself by pi, and then the right one is actually being rotated, also by pi. So you can see it does one full rotation, and runtime is 2 seconds. So that's how long it takes for the entire animation to complete. And then we're having it wait for another 2 seconds after the fact. Okay. So again, in this case, there's some quirks for the .animate, right? So when you use that, it actually uses the object's starting state and the end state, and then it sort of merges the two, right? That's why you saw that it, instead of actually rotating this way, it rotated in itself. All right. So again, you do need to be careful about which one you're using, because these two, while they might seem like they do the same exact thing initially, they do not. And again, you can play that one more time actually. And again, you'll have an archive or all the videos that you generate over here. So if you did want to pull one up again, you can just pull it up from there. And again, this is the different rotations. So you can see it's sort of, instead of it, like they end up rotating the same way, It's just the rotation that happens over here happens in a much different fashion than the one over here. So than the one on the right. So the way that you actually define the rotations or the way that you say, hey, this is how I want it to rotate also matters, right? Any questions on that one? That was a little bit of a confusing, sort of confusing example on Manim. All right. If not, it is closing in on an hour. So so we'll take a maybe a less than 10-minute break. So we'll be back at, for me, it's 7 o'clock p.m. So whatever it's going to be 9 minutes from now, or 8 minutes from now, wherever you are, we'll reconvene then. And again, if you do have any questions in the meantime, put it in the chat, and grab a drink of water, and yeah, I will see you back here in 8 minutes. All right. Again, if you have any questions, do put it in the chat or put it in the comments, and then I will get to that shortly once we get back. All right. Hopefully you all enjoyed that break. Let's move this, pause the song. Okay. Hopefully y'all got some drink of water and are ready to go. I'm not seeing any questions in the chat or anything at all, actually. So it makes me a little afraid that everyone's gone, but hopefully that is not the case. Everyone is following along. Um, so just as a quick recap, we're going to go through all this one more time. We started off by creating a circle, and this was again a very, very simple building block of Manim. You just create a circle, and we went over how each class is actually structured very similarly for every single one of the for anything that you want to do basically in Manim. So over here we have a class called create circle. We're actually constructing the class, and then or constructing the method, then we are actually creating our circle, setting the color and transparency over here, and then actually playing it using self.play. And again, the command to play something is always going to be a verb. So in this case, it was create. Over here, in our next one, where in our next example, where we transformed a square into a circle, we use transform and fade out. Then over here, when we were actually experimenting with text, we have write, and then we have different shapes. And again, we just use create over here for our LaTeX example, which unfortunately did not work on my end, but hopefully worked on yours. We use write. And then lastly, over here, we used animate or rotate. So again, there were different ways of doing rotation, and we saw how just the syntax might change the way that rotations or things look in Manim. Because again, it is animation, it is very visual. The key thing to keep in mind here is that because the beginning and ending are the same, all this does over here is merges everything into one and immediately rotates the square to the end position, whereas this rotate right here actually slowly runs it so that the rotation is done a lot slower and it's more visual. All right. So we've done all of that. Now let's actually get into something a little bit more interesting. It's going to be graphing. Now, graphing does require LaTeX, usually. I'm going to be doing another, maybe a little hacky version of it, where it does not require LaTeX. So some of the, let's say, axes may not be fully flushed out, for example, but it will or it should still work. So bear with me. All right, I'm not seeing any questions, so we can get right into it. So let's go into uh, our graphing example. Okay, so again, very similar structure to before. So class graphing example and scene, then construct pass itself and go. So for here, we want to actually define the axes. So our axes are going to be axes, and we're going to have our x range, which in this case we can set to a very small graph. So let's go with -3, 3, and 1. So what this is doing here is saying what the bottom value should be, what the floor value should be. This is the uppermost value, and this is the essentially the steps. So about how much are you trying to skip? So we just go blocks of 1 in this case. Then we want to do the same for the y range, and we can set that to, let's go with -2. Upper is 2, skip by 1, and then we want to actually configure our axis. So let's do axis config. And in this case, we just want to set the color of it. So we can do color equal to white, or colon, and then white. So very basic looking graph. Now we actually want to plot this, right? So the way we want to do that is using graph equals, and then we set it to the axes. So axes dot plot. And over here, we're going to be using a lambda function to be plotting it. So let's do lam x to, and then we can set the color to blue. Yeah, that looks right. And then normally here, you'd also add graph labels. I'm going to add it just so that anyone who does have LaTeX working, the LaTeX installation working, can also add the labels. So let's do that. Graph labels equals axes dot get graph label label, and then you want to actually add the graph. So unfortunately, this won't work on my machine, which is why I'm going to leave this commented out, but it should work on yours if you have a working LaTeX installation. And then we just want to, now that we've done all the setup for it, we want to actually play this. Seeing a red squiggly line here. Okay, it should have been closed. So let's move on to actually playing this animation. So self.play. Create a axis and create the graph. There we go. And then we just want it to show there for a little bit. So then we are going to wait. For 2 seconds. Okay, now let's actually run this. So copy this, paste this here. graphing example, and let's run it. Ooh, we got an invalid syntax. Okay. Did we forget a comma? Yes, we did. And axis config, color, we're set to white. Okay, that should be correct. Let's try this now. Ooh, color is white, invalid syntax. Um, hmm. Okay, for axis config, we want to make sure we're going to remove that for now. And let's try running it without that. Okay, there we go. So over here, if we run this, we can see that the axes were created. I guess the default is white, so we didn't need this. Um, but again, if you did want to configure it to a different color, you would use that and then use a different color. But in this instance, you can see that we were able to graph our first animation, right? So we have our actual graph that got plotted over here in blue. And that's, again, just a lambda function for x squared, right? So y equals x squared, a very simple parabola over here, being shown in blue. And then we actually played this entire thing where we first created the axes and created the graph simultaneously. Okay. And congratulations, you're able to get a working example of a graph or a working animation of a graph on your laptops now. So great work there. Let me see if anyone has any questions. Hmm. It's looking like no questions. Someone did say, oh, hopefully, you know, you're also following along and we're able to get that working on your end as well. So again, this is just the very beginning. There's so much more that you can do with Manim, right? You can go into make very, very complex sort of animations, different shapes, different transformations, different morphs. It's incredible. You know, it's an incredible tool that's very, very powerful. Okay. So I'm just going to leave this up here for a few more minutes to make sure everyone's able to get it working on their machines. And then we will move on to something a little more complicated. In the meantime, I'm just trying to get my LaTeX to work. Unfortunately, it is not doing anything I am asking it to do. So they always wondered what the three blue, one brown used to make animations with. Yes, well, now you know. And you can honestly see the similarities too between this graph that we just created and all the three blue or three blue, one brown animations. They all look very similar to this. So I'm glad you can see the similarities and see how, you know, the code that he uses is now open source. It's maintained by a huge number of people. So yeah, it's very, very interesting to see. And yeah, I am glad you can appreciate that as well. That is something that's cool for sure. Okay, just gonna give it maybe a minute or two more. Then we'll go on to something maybe a little bit more difficult. Is there any other questions? So, no. And yeah, if you do want to see much more advanced versions of sort of what we're doing here right now, I do recommend checking out Three Blue One Brown's channel. It's a YouTube channel, some really cool stuff on there, and he uses Manim actually for all of his animations. So it, it's really cool to see something that you worked on working there. And again, I'm just trying to debug this lack of latex, which is really annoying. And again, if this does not work, then it shouldn't be a huge issue. If latex is working for you, do let me know in the chat. That way I know that I'm not, or yeah, I'm not doing this for nobody. If you don't want latex or do not have that installed, also let me know. That way I know that I should focus on not actually doing any very latex specific stuff. LaTeX wasn't working, or somebody else as well. Yeah, it can be very finicky. I know it's like a huge package as well. I think when I was downloading it, it took almost an hour. It was like 5 gigs of just a ton of different files. I think it was just all the different ways. Again, you can uh, actually have math be written. So a lot of it was very heavy. Um, Oma says they have LaTeX installed and working, but still debugging Manim and its related stuff. Wow. Okay. Do you know what the issue that you're getting is for Manim specifically? Do let us know. That way we can try and help. Dependency called ffmpeg. Oh yeah, you just need to install that. So that should just be pip install ffmpeg, and that should take care of it. I think I might have had a similar issue as well. It should just be a pip install. It's a very it's like an annoying package that you sometimes need to install separately. But if you just run this pip install command for pip install ffmpeg, then that should work. And let me know if it does. Also, let me know if it doesn't. That would help. Okay. Someone else said, finally managed to set up a virtual environment and install Manim, but it seems like it didn't install the dependency ffmpeg. Yes. So again, it should be the same exact thing, just pip install ffmpeg. And let me know if that works. So it looks like a lot of people are having similar issues. So again, just try and make sure that you have it pip installed, and that should take care of it. Because next up, we're going to be going into something a lot heavier. So we'll see. Let's see. Oma said, we found a solution on Manim docs that for Windows, they need to install Manim using Choco Package Manager. That's interesting. Okay, I did not know that. And it seems it's going to work. All right, that's good. So again, if you're on Windows and nothing else is working, try to install Manim using Choco Package Manager. That could actually be helpful. Yeah, Chocolate is also a different package manager that could have. So if nothing else works, if all else fails, do use a package manager. I know Windows, the way they work with files, or the operating system works with files, is very different and can be extremely annoying with Python because you need to make sure all the correct paths are added to like a path file. So it can get complicated and all over the place very fast. And yeah, if you are having issues with that, looks like Oma did link the docs, so check those out as well. Okay, let's move on. Actually, let's wait for a couple of you all at least to get this thing working. And just let me know if you're able to install Manim and FFmpeg, and that works. If not, then do try using Chocolatey. That should take care of it. And I'm going to take a quick water break. All right. Hopefully, you all were able to get this implemented and also able to see this actually working with a graphing example over here. All right. Now, next up, what we're going to be doing is something a lot more complicated. And this is going to be actually a really interesting use of Manim and an example of sort of how 3 Blue 1 Brown creates some of his animations. So what we're going to be doing is making a very simple explanation on how linear functions work. So really quickly, I'm just going to pull up this video right here. So we're going to be making something like this. So we're going to have axes over here, and it's going to be creating the graph first, and then actually saying, okay, this is what we're doing. We're explaining y equals mx plus b. Then it's going to draw a line through the graph and say, hey, this is the y-intercept, where the y-intercept in this case is 2, and then say what the slope is. The slope in this case is 1. Then it's going to move the graph upwards and say, okay, the y-intercept is the same, but the new slope in this case is m equals 2. And then it's just going to fade everything out, and that's it. Again, we couldn't do too many fancy things with the letters because of the lack of LaTeX, so I had to find a solution that worked around that. But hopefully this should work, and it should work well. All right, so hopefully you all are excited to start working on this. Do let me know if I'm going too fast at any point. You need me to go back to a different section, or if you need me to slow down. But that is the next, really the next thing that we're going to be working on, and hopefully the one thing that we're going to work on until the end. And then we should all, by the end of this, have a working example of, or a working animation of an explanation on how to actually graph or y equals mx plus b. Any questions before we get into that? Okay, not seeing anything yet. Again, if you do have something, just post it in there, and we'll get into it. So let's get started. The specific class we're going to call explain linear function. So class explain linear function, right? And just like always, we are passing in the scene, then construct self. And let's begin. So first and foremost, again, just like before, we needed our axes. So honestly, we can just copy and paste our axes from here. But again, we will need to edit these because we're not doing the exact same thing. So axes, over here we have our axes set to this. It's commented. There we go. So X range, let's change the X range to be from -10 to 10. And jump to 1. Y range, we want it to be a nice even square. So change this to be the same. And then we also want the lengths. So let's define the lengths over here. X length, let's set to 10. And Y length to 6. And don't want to forget the commas. And then actually configure the axes. So axis config. And hopefully this one works this time. If not, then we can just delete it. Equal to. Or honestly, let's keep it light. That way we don't need to mess with this too much. All right, so everyone should just have the axes defined. Again, the X range is going to be from -10 to 10. Same thing with the Y range. And we'll just wait for everyone to get that working. So we can zoom in over here. Zoom in is Command equals. Okay, that's how you zoom in. There we go. That should be a little bit easier to see now. Okay, so no questions, so we can move on. So next we want to actually just, this is the part that we're sort of hacky, workaround around LaTeX. We're going to add the labels, and we have to do this because we're not using LaTeX. If we were using LaTeX, it would be a lot easier. But in this case, we have to do a full loop. So for X in range, let's go from -10 to 11, skip by 2. We are going to set X label equal to text. And X, oops. Next to, and the axis dot cp to from x0 down with a buffer of 0.1. And then self add this to the X label. Okay, so basically what this is doing is adding the labels because we do not have access to LaTeX. So if we did, it is a fat package, but we'd avoid having to write code that looks like this. But basically what this is doing is actually adding labels in. Do I still have the video up? Let me pull that up again. So we're basically just adding all these labels over here, and we're making sure that they are next to these axes, but they're off by like a value of 0.1. That's what the buffer is. That way it's not overlapping. So again, this isn't the cleanest looking thing in the world, right? With the axes specifically, or the axis labels. But that's why again it's 0, 2, 4, 6, 8 because we're skipping by 2. And this right here, we just wrote the X labels, so you can see it was down. Now for the right labels, we need to shift it left because we don't want it exactly on top of this. So that's what we're going to be doing next. All right, so honestly, we could copy and paste our X label 1 and then just translate it completely over for Y. So let me actually shrink this because we don't need all of it here right now. I can also collapse this because we don't need that either. So in this case, wow, for Y in range -10, 11, 2, because again, it's not inclusive. We want the Y label here, not the X label, to be text. And then over here, we want it to be f of Y, the font size to be 18, next to axes C2P, change this to Y. And instead of it being X comma 0, it's going to be 0 comma Y because we want to make sure it's in the Y axis. Then, like we said, we're shifting this to the left and buffer can still be 0.1, self.add Y label. So now we added the Y labels here. All right. Now let's actually add the axes labels. Axis labels, and this is going to be, let's say, x-axis label. Set to, and again, we need to use text here because we can't use math text. X, we'll set the font size equal to, let's say something slightly larger. Oh, I closed it out again. Don't know why I keep doing that. Well, let's change it to 24 so that the actual, it's more obvious. And then color equals, just keep it at white. We'll make that defined. And again, we want this to be next to the end of the axis. So we want this to be at axis dot, make sure, okay, so it'll be at axis dot x axis dot get end. Okay, so this is going to be the actual x-axis, and we want to make sure that this is on the right-hand side. So next to x-axis get end, comma, on the right, comma, let's have our buff equal to 0.3 here. Okay, then we can honestly just copy and paste this again for Y, but again, be sure to change everything that needs to be changed. Otherwise, we might run into some interesting errors. So Y-axis label, we have the text set to Y. We set the font size to the same, the color to the same. Over here, we want it to be next to the Y-axis, end of the Y-axis. And then we want this to be, instead of on the right, let's change this to up and buffer it to 0.3. Okay. And then what we want to do is actually draw the border and fill it out. So let's do self.play. Draw border, then fill. And again, this is something that's built into Manim, so you'd be surprised what you might find if you go digging deep enough into the Manim documentation. So draw border, then fill the axes. And then we want to actually write the x-axis label and write the y-axis label. So x-axis label and comma right the y-axis label. Okay, now that we have our first play, let's actually see if this works, right? We want to make sure we have no errors as of right now. So if we just copy the class name and we try and run it using a Manim -pql, we can do explain linear function, run that, and we can see that it is showing this animation right here. And this looks correct for the most part, right? So we have the labels exactly where we want them. Let's play that. And awesome. It looks like it created the X and Y labels exactly where we asked them to, right? The Y labels at the top, the X labels on the right-hand side, and everything looks exactly as it should. Um, yeah. And again, if we wanted to, we could clean up the zeros in the middle, but we won't deal with that right now, just because we do want to make sure we finish at least this entire animation by the end. So is everyone with me so far? This is like checkpoint number 1. We'll try and do a checkpoint every time we need to play something. That way we can see if everything we did was correct and we're not making any major mistakes. And again, I will be uploading all of this code to GitHub after the stream. So keep an eye out in the beginner weeks channel. That way you can have access to this if you aren't able to complete it alongside me during the stream. But again, I do recommend you try and follow along, especially on your own machine, because the feeling of writing it yourself and then hitting run and it actually showing up is way different than if you just copy and paste something from somewhere else, right? So we'll give it a couple more minutes or a few more seconds actually, and then move on. Looks like everyone's hard at work coding this up, which is great. I'm not seeing too much activity in the comments right now. So again, just a quick recap of what we just did. The first thing we did was, again, define the class and the actual function. Then we defined our axes. So our axes in the X range are the same as the one in the Y range by 10. We set our lengths over here. And then we added all the labels. So you can see that we had to do this manually due to the lack of LaTeX. So we had to do a for loop and basically iterate and have every single one of the axes printed next to the other one. And then we added the X label, then did the same exact thing for the Y labels. Then we actually wanted to play those. So draw the border, then fill for all the axes. And then it wrote out the X axis label and the Y axis label exactly where we wanted it to. And that's basically step 1. Okay, are we ready to move on to step 2? Am I going too fast, too slow? Do let me know. The feedback is important. That way I know that I'm going at a good pace for the audience instead of just talking to myself. Okay, looking like nothing going on in the chat. So I am going to assume that it is safe to move on. Again, I'll be starting off from the bottom of the screen. That way it's easy to see everything else that happened at the top. All right. Now that we've added the graph, right, this is really the base of what we wanted. We really just wanted an outline over there. Now we can actually start demonstrating the slope and the y-intercept. So let's do that really quick. So we'll have to first have the actual text for the explanation. So let's do that. Slope and y-intercept demo. All right. So let's first start with the actual explanation text. So what are we doing? Explanation text is going to be a mobject. Actually, these things are called mobjects, these Manim objects. It's going to be some text where we just write, we are explaining linear functions. And then we can set the font size. We want this to be the biggest and boldest thing here because it is the explanation. So let's say the font size It's going to be, let's go with 36 is a reliable number, and set the color equal to something that's big, bold, maybe yellow. Okay. And then we want it to be at the top edge, right? So let's say explanation text dot to edge, and the to edge function is sort of how you set something or send something to a specific edge. So let's go with up. So this is going to be at the very, very top. Okay. And then we want to self.play, actually writing this animation. So write the explanation text. Okay, now that we've hit another self.play, this is our checkpoint to see if everything we've done to or so far looks good. So we'll run the same exact command. And now again, we start off the same, we hit play, we get our axes built, and then it says explaining linear functions, which is great. That's exactly what we're looking for. Okay, so far it's looking so good. Okay, someone said the pace is good. That's great. I'm glad the pace is all right. So we're just going to give it a couple more minutes so that people can catch up. And again, they're able to actually see how the slope works and have the text show up on their screen. Okay, moving on, let's add a new example line, right? So this is going to be a line that goes through this. Let's have the slope be 1 and the y-intercept equal to 2, right? We don't want it to make it too easy going through 0. That's not a great explanation. So let's set a line with in y equals mx plus b. Let's set m, which is the slope, equal to 1. And let's set b, which is the y-intercept, equal to 2. Okay? And then over here, we want m equal to 1, b equal to 2. And let's actually create this line. So line is going to be axis dot plot. And this makes it really easy to plot different functions on a graph. And again, for this, we're going to be using a lambda function. It should be pretty straightforward. Lambda x, this is just going to be m times x plus b. And we really don't need to worry about parentheses here because of order of operations. But if you do want it to look a little cleaner, you can absolutely feel free to add those. And then we want the x range here to be from -10 all the way to +10. So the x range in this case just indicates from where to where are we going to be drawing this, or are we plotting this graph, or this line, sorry. So we're going to do from -10 all the way up to 10. And let's set the color equal to blue. All right, this color is blue. Let's actually have a label for this line as well, right? We have a line, but what is it there for? So let's have the line label equal to text. And this is going to be, because we're explaining linear inequalities, let's do y equals mx plus b. I think that's, well, yeah, that should be good enough for formatting. And then set the font size here to, what was the previous one that we used for labels? 24. So font size we can use for 24. Font size equals 24. And we can set this color to blue as well. And we want this to be next to the line, right? So let's do dot next to the line, above the line. And let's set a above to equal 1. Okay, Now let's try to actually play this using self.play. So self.play, and let's actually create this line and write the line label, right? So those are the two things that we want to do. So self.play, first thing what we want to do is create line, right? So this should create the line. At the same time, we want to write, again, these are the verbs. So anytime you want to do something, you put in the verb or the action that you're trying to do, and that's usually going to be some sort of action item in self.play. So write the line label here. And we want to give it a couple times to rest, a little bit of time for us to actually see what's going on. So we can add a self.wait here of, let's go with 3. 3 should be plenty. Okay, so this right here is going to be our line with m equals 1, b equals 2, and again, every time we have a self.play, that's a checkpoint, so let's run it from here. Make sure everything looks the way we expect it to. And it's generating those animations. We have this thing here. Let's take a look at it. Okay, this is correct. This is what we already made. We had explaining linear functions. Okay, so it's able to draw that line, and it's saying y equals mx plus b. It's interesting. We will take a look at that. But we were able to get the line drawn, and you can see that the line intercepts at 2, right? At +2, and it is a 1-by-1 line. So that is all looking good so far. The reason it doesn't look like it is because we set the distance between these to not 1. Now, if we did want to change that and make it so that all of these looked the same, we can actually go up and change the x length or the y length to be, instead of 6, let's change it to 10 and see how that looks. All right. So if we generate this again, we can see that it has to regenerate all the animations, but now it does look a little bit more even, like a 1-by-1. Now, the issue with this is it does go off the screen because we don't have enough space for it, but this one makes it a lot more obvious that it is a slope of 1. So again, I'm going to change this back to 6 just so that it's easier for us to visualize or for us to see the entire thing on one screen, but you can change it to fit your screen dimensions however you'd like. Again, this is your project. Feel free to do whatever you want with it. Okay. Everyone doing all right? As Chris said, this is a real example of Matt's applied programming and just 5 to 7 viewers to see this. Unfortunately, not a lot of people, but hey, you all can also, tell other people about it. You can make your own animations, make your own math videos. You could do a whole lot with this. If you make this for maybe a math class or something, could be really impressive to, your professors or your teachers, and you might get extra credit for something. So hey, there's, no shortage of things you can do with this. So it's not about how many people are in the stream, but about how or whether or not you actually do something with it. So hopefully, you all will be making your own, math animations. I do advise, or I do ask you all, if you do end up making some animations, send them to me or put them in the MLH Discord, and just ping me or at my name and let me know, hey, this is what I made using Manim. And if I see it, I'd say, hey, that's really cool. It all started off from this stream right here. Even this right here, if you want to put it in the chat, I think other people are going to see what you all made, and they're going to be jealous, and then they might join for the next. And you can also join and tell them, hey, I was there for the very first one. Okay, so hopefully you all were able to get this this much done, right? Up until actually creating the line with m equals 1 and b equals 2. Now let's move on to actually morphing this. Okay, so next up, let's actually show the y, show b. Let's do that. Show y intercept And what we're going to be doing here is, let's go with b dot. That's going to be our variable name is going to be a dot because we just want to make it very clear that, hey, this is where the y-intercept is. So that's going to be axis dot c to p at 0 comma b, whatever b is. In this case, it is 2. And we want to make this really stand out. And because we are using blue, a good color that might stand out in this instance might be green. So we're going to have a dot for our y-intercept, and let's actually label that as well. B label equals, and again, this is going to be some text. Y-intercept B equals 2 in this case. And set the font size to the same as earlier, which was 24. So font size equals 24. Oops, not minus, equals 24. And we want the color, in this case, to equal green. Okay. Now I want this not to be directly on top of, but next to our b dot. On the right-hand side. That closes that out. Do I need to close anything else out? No. Okay. So this is going to be that on the right. All right. So then we can actually have another checkpoint for ourselves. So self.play. And we actually want this y-intercept to show up on the screen. So let's have that actually fade in this time. So fade in the b dot, and let's write in the b label. So write b underscore label, and that should have everything there. And then we just want to self.wait for maybe 2 seconds so that everything, or we give it enough time to for the user to digest. So if you run that again, it generates all those. Okay, no errors. This is a surprising streak of no errors. I think I just jinxed myself, but we'll see. So again, the classic explaining linear functions. We get our linear function over here, and we wait 3 seconds. Then we have a green dot that shows up with y-intercept b equals 2. Okay, now b over here is kind of ambiguous. So I'm actually going to go up here and change this title from explaining linear functions to explaining y equals mx plus b. That way it is a little bit more clear what we're doing here. Okay, so that means everything is working so far as we expect. Now we are running short on time, so we are going to unfortunately have to move on. But if you do have any questions, do let me know. I'm going to go to the chat really quickly. Okay, looks like nothing's there. That's great. So next is really just the ending of it, right? We just want to animate the changing slope and then finish it off. So animate changing slope here. And here what we want to do is the slope itself is going to be m, right? We've already defined that. So let's play that. Self.play the fade out the slope line. let's see, we got this, we have changing slope. We just wrote our line label and our B label. Did we skip a step? Show the y-intercept of b equals 2. And we did not. We just need 2 first. Show the slope. So right now we don't have the slope actually written, right? So let's show the slope first. So show slope. So we'll make it really obvious what the slope is. And in this case, the slope is m. So we can keep track of that. In this case, let's set the slope line equal to line where the axes are similar to what we had earlier. C2P 0, comma, yeah, we're going to have it from 0 to b, comma, axis dot C2P at 1, comma, m plus b, whatever m and b are. In this case, we want to set this to something even more, something that will stand out even more, which is maybe orange. And let's actually set the other information, like the stroke width in this case, equal to 4. Okay, so this is going to be our slope itself. So this is going to be really bold. It'll show up. And then let's actually label this as well. So slope label is going to be text once again. And similar to what we had earlier, let's actually set the text. So slope, in this case, m equals 1. And then we want to actually set the font size to the same as before, which is 24. Set the color, so it matches the other color, to orange, for the color of the slope. And then we want to set this to be, again, next to the slope. So next to the slope line, comma, set this to up, and set the buffer 0.2. Next, we want to actually play this. So let's have this show up, self.play, and let's actually create the slope line. Again, similar to before, create the slope line, and we want to write the slope label right next to it. And let's have that wait for maybe 1 second. And I am running low on time, but we do need to use this as a checkpoint to make sure that we have no errors. As you can see, we have an error over here. C2P is not defined. Let's see where we're getting that. Interesting. Okay, so we have our slope line to line axis dot C to P of 0B and axis C to P of 1, comma, M plus B. Color equals orange, strip width to 4. Oh. This is a bad time for something to fail, but this is why we have checkpoints. Oh, okay, it's a comma instead of a dot. That would do it. Axis dot. Okay, there we go. So that should run it properly now. Unfortunately, we don't have the time to run it. We're just going to hope it works. Actually, let's make sure it works. Always good to verify. Okay, good. So it does work. And then we're going to speed through the end, which is we have the slope. Now we need to just animate the changing of the slope and then end it out. So animate changing slope. And in this case, we are going to have the current slope line fade out. So fade out the slope line and fade out the slope label. Okay, then we want our new m to equal 2, right? We have a new slope. And let's have our new line. And it'll be very similar to our first line where we have this axis.plot lambda. Where's that? So we can just copy and paste this over, honestly. And all we need to do here is change the mx plus b so that it is new m times x plus b. Okay. And let's change the color in this case to red. All right. Now we do need to speed through this. So new slope label. And this is going to be similar to we had the other label up here for line label, text. Let's copy this one. Okay, slope now is m equals 2. Font size, let's change the color to red. Slope line is going to be new line. Just do this, font size, color. Let's just do 2-edge. That way we don't need to worry about everything, and just down. So it's going to be at the very bottom. And we can play this. Self.play, this animation right here. Transform the line into the new line. And write the new slope label. Okay, and then we just want this to self.wait for maybe 2 seconds. Okay, hopefully this all works. This is pretty much what we are looking for. Okay, all the 11 animations played, and this really is the moment of truth here. So we have everything that built over here, explaining y equals mx plus b. We have our initial line, and then the dot should show up and say, okay, this right here is the y-intercept, which is b equals 2, and the slope, which is this, is m equals 1. Nice. Now this changed the slope to m equals 2, and that is our explanation. So awesome. This entire thing did work as expected, and hopefully you all were able to catch that. Again, if you weren't, I will be posting all of this to a GitHub. Do keep an eye out in the Beginners Week channel for that. Now, unfortunately, my time is up, so I do need to go. But if you do have any questions, just ping me in the Discord. I'm seeing there are some questions. Do I have to install any particular extensions in VS Code for this code to work? No, you do just need to pip install Manim, which is the animation library that we're using from Python, and that should work. All right. Again, thank you all so much for joining us today or joining me today. And hopefully you all learned something new. And again, if you do make anything awesome with Manim, do put it in the MLH Discord and do make sure to tag me. All right. Have a great day, you all. And hopefully I'll see you all at the next stream. Bye-bye.